set theory review. We have a midterm coming up, so I'm going to go over some, and might as well make something other people can use. I'm going to go over the axioms and try and show something about them. For example, the first axiom we do is usually called, I think it might always be called, I don't know, extensionality axiom. Basically, this says that if two sets have the same members, so you want to show that set A equals set B, this needs to be defined because it's not really clear a priori. I mean, you don't really want to write it that way anyway, because that's unclear what that equals is supposed to mean. Well, no, you can write that way. That's fine. You just have to define it first. So it says if the members of this are exactly the same as the members of this, and vice versa, then they're equal. So what you write is for all the sets A, for all B, for all X, such that X is in A, if and only if X is in B. Remember this thing. This basically gives you that, gives you what you want, which is that everything and no more. Everything in one set is contained in the other set. Nothing else is contained in the other set. This implies that A equals B. And check to make sure I did that formally correctly, according to the book anyway. Okay, which I'm going to go with for now. Okay, for all. Oh, and this thing right here, you should always realize what this is. That says for all X that satisfy this condition. That's important because it's not immediately obvious if you're not familiar with symbolic language, or formal language, I suppose, and you really need to understand that idea, because it's basically how you write things formally. The next axiom is the empty set axiom. Empty set axiom, which says that there exists a set having no members. You write that formally as there exists a B, says that for all X, X is not in B. I believe you need to define a universe where your X sits. No, because you're quantifying. So you would take, of course, okay, that's fine. Because otherwise you couldn't say for all A and for all B in the second one. So, okay, I'll buy that. You can say for all X sets, X is not in B. By the way, you can talk about this object, this for all X, all sets object, but it's not a set. The set of all, there's no set of all sets. That's called Russell, I think. Basically, it's in short, it's too big. I'll prove it a little bit later, or at least show it. I can't really. Yeah, you can prove it. So now there's the pairing axiom. Pairing axiom. Oh, why do we want this, by the way? Why do we want that? We want to have a set. That's very sad. We want to have some building blocks. You want to have like a building blocks to build your set theory in. So you don't want to be stuck with no sets. You have to know something. Kind of like you can't spell. Like if you didn't have letters, you couldn't spell very well, or at all, really. You need at least one letter, and then you could just make strings of letters, and you could do it. But you need something to start with, and the empty set is one. Further, we have the pairing axiom. The pairing axiom says, for any sets U and V, there is a set having as members just U and V. Formally, that's for all U and for all V, there exists a B. This is going to look ugly, but I'll explain it. Such that for all X, if X is in B, or X is in B if and only if X equals U or X equals V. This is an important axiom. Why? So for all U, okay, pick sets U. Pick a set V. There is another set B such that for every X satisfying this condition, that X is in B, we either have that X is in U or X is in V. Now this may seem, again, if you're not used to set theory, this seems a little bit not obtuse, but it seems silly, but it's not. Basically, set theory is trying, or tried rather. It has issues, but what it tries to be is the when it was first conceived, it was supposed to be the representation for all mathematics. It ends up having issues, but if you want to do something like that, you need to define everything. You can't just say, oh, I have 1 and I have 2, so it's obvious that I can make that set. By the way, these have to be sets, or else that doesn't make any sense. We still have, that's a set, and that's a set. If we give them a definition. But you can't just assert that these things exist. You have to have something to start with, and then you can build things from that. That's why you need the empty set axiom. So you have one set to work with, precisely the set that contains nothing. There's the power set axiom. Spell it right? Yes. That says for all A, there exists B, except for all X, where X is in B. For all X, X is in B if and only if X is a subset of A. So you're taking the power set of A. This asserts that... does it assert that it's necessary? Yes. Okay, so why do we want this? We want this because it helps you construct sets. Really, a lot of this may seem unreasonable or kind of silly if you're not used to formal math. But why we need this is because otherwise we're going to have a lot of trouble defining sets. Like a lot of trouble. Pairing, if we only have pairing and not power set, I'll find something that can't be proved, that is not provably a set if you don't have power set axiom. I'll have to think about it though. Anyway, you're saying that pick any set. There exists a set. This is the important part really, right here. These existentials are important in axioms. This says that this thing exists. And it's an axiom because you can't really know that in any real way without stating... You can't prove it from the other axioms, which is interesting. I will also I'll try and find a model where you don't... A universe where the power set axiom doesn't work, but the other three do. That might take a while. So I'm skipping one in Anderton. I'm using elements of set theory. Elements of set theory. By Anderton. Herbert E. H.B. Anderton. And I'm going to come back when in the next video we'll have the union axiom, the real one. There's one in Enderton that's preliminary. That's not quite the one you want. So I'm going to skip that one. If you have Enderton, you can look it up. It's on page 18 of the Enderton that I have. I don't know if there's a difference between the other ones, but anyway, this is going up in a minute.